All right, let's look at number 4. All right, we got a lot of text here, so you guys can read this paragraph on your own about carbon. And then the question is down below here. The current amount of radioactive carbon-14 present in the remains of animal bones can be measured, and the ratio of the current amount of carbon-14 to its initial amount can be used to determine its age. The last ratio is described by the function here. Okay, so this is the function that we're going to be using, which is the same as this function here, but it got cut off, that t. T is the time in years. So I'm going to write this equation on my paper. It was CT is equal to 0.5, which is the same thing as 1/2. So we're talking about half-life here. I could write 1/2. To the T over, what was it? 5,730. So is T in years? Whoa, T is in years. That means it halves the life every 5,730 years. Yeah, that's what it says here. That's crazy. So carbon doesn't decay that often. It's kind of cool. Okay, so the question says, how old is the animal bone that's lost 40% of its initial carbon? My A value here, what is my A value? It's an invisible 1. So when we say invisible 1, that means 100%. So we're talking about like 100% of what we started with. That makes sense. We have a 1 here. So it's like C of T is equal to 1 times 0.5 to the T over 5,730, where T is in years. So if I want to figure out, the question said, sorry, I keep going back and forth. How old is an animal bone that has lost 40% of its initial carbon? Tricky part here. So I'm going to be plugging something in for this value, this Y value or C of T value here. If I lose 40%, do not put 40% here, or 0.4. The reason for that is I want to figure out how much carbon I have left. How much carbon is left. So if I lose 40%, I have 60% left. And this is the time to figure out how much carbon I currently have. So that means if I start out with 1, 60% of 1 is, move the decimal place over, 0.6. So 0.6 is equal to 1 times 0.5 to the T over 5,730. Now I really don't need that 1 here. So it's not like you have to divide by 1 first or anything, because it's just invisible. 0.6 divided by 1, which is 0.6. So now that I have my equation set up, I take the log of both sides. So I'm going to have log of 0.6 is equal to log 0.5 to the T over 5,730. And then again, the whole point of logs is to get rid of our exponent. The inverse operation of exponentials is logarithms. So now I have log of 0.6 is equal to T over 5,730. Now, what I'm solving for is this T. So I want to get everything else alone. Since I'm dividing by 5,730, the inverse operation of division is multiplication. So I can multiply by 5,730 to cross these out. So I have 5,730 times log 0.6 is equal to, still focusing on my T here. Oops, I forgot the log here. log 0.5. Now to get t alone, I divide by log 0.5. So t is equal to 5,730 times log 0.6 over log 0.5. If I didn't have access to a calculator, then this would just be 5,730 times log with a base of 0.5 and a normal number of 0.6. But you guys do have access to a calculator, so I want you to use an online calculator here. So we have 5,730 times log of 0.6 or 0.6, it doesn't matter. See what that equals, and then divide that by log 0.5, and we get 4,222, or 23 if I'm rounding, years. So for carbon to decrease 40%, so we have 60% of what we started with, it's going to take 4,223 years. That's a long time. All right, so 4,223 years.